Good afternoon, ladies and gentlemen. In this short video, I'm going to be doing the preparation problems for practice C in chapter 14, which is about total internal reflection. So I draw your attention to your handout that I made for you guys that summarizes this chapter. On the very bottom is a summary of what means a critical angle. So now you know that a light coming into a medium changes speed, so the angle will also change, it'll be bent. But what if it bends in such a way that nothing gets reflected, but everything gets refracted back into the material? So here's an example where your incident light ray is coming from the glass out to the air at such an angle that a specific angle is perpendicular right on the surface, I should say, right on the surface of the second medium, in this case the air. If it's greater than that angle, then it'll be all reflected back in. So here's an example on page 506. There's a good photograph, really good photograph. It says this photo demonstrates several paths of light radiate from the bottom of an aquarium. So here's a light source, and you can see it's going out in a bunch of different angles from the bottom of the aquarium. So it's from water, and then it's going out to air. At the critical angle theta sub c, theta c, so here's an example of what's going on here, or I should say a schematic. So some of it, it's going 90 degrees, it goes straight out at a little angle, then it gets bent at a greater angle, bent even more, at greater angle bent, and it's exactly on the level of the water, and then greater, it gets bent back in. So at the critical angle, the light ray will travel parallel to the boundary between the air and the water. That's this one right here. It's horizontal, pointing to the right. But any rays at an angle of incidence greater than theta c will be totally internally reflected at the boundary. So it goes all the way back in, and that's what you see happening right here. This angle is great enough that none of them left the water, none of them left out to the air. It just bent right back into the water. So what we're going to try to figure out in this section is the critical angle. All right, huge book. So there we go. And what is the equation? It's really simple. It has to do, again, with the index of refraction. The index of refraction. And the index of refraction depends on what media you're in. So the sign of that critical angle is just the index of refraction of the second medium. So it depends on what direction you're going in. So here we start from the glass out to the air. So here would be the index of refraction of the second medium would be the index of refraction of air, which we know is 1.000, divided by the index of refraction of the first medium. So whatever the index of refraction here, and then of course to find out what the angle is, you just take the arc sign. Okay, so if it's greater than that critical, we call that the critical angle. If it's greater than the critical angle, then you'll have total internal reflection. So what are some indices of refraction, index of refraction? So this is on page 490 of your textbook, 490. I can't show this, too big. Page 490. And so you're going to need to look at this for the homework. And so here we have for cubic zirconium for diamond, look at that, pretty big. Fluorite, quartz, glass, crown glass, flint glass, etc. Zirconium. Notice how cubic zirconium versus zirconium, it's not the same thing. Glycerin, water, ethyl alcohol, and here are your indices. Index of, so always right, it's 3 zeros. For air, it's 1.000293. Carbon dioxide, 1.000450. Okay, and these are at set specific temperatures, by the way. Okay, so let's take a look at the problem, which I have here. Number 1, it says calculate, this is on page 516. Calculate the critical angle for light going from glycerin into air, So what angle would I need for total critical, well, what is the critical angle? And if it exceeds that, then it would be total internal reflection. All right, so here's what I wrote down. Well, not much. I just wrote down, well, from glycerin to air. So I come back to this book here, and I need the index for glycerin is 1.473. So let me write that down. For glycerin, N is 1.7, yes, I'm going to do 1.473. That's for glycerin. And from air, N is 1.00. And all we need is the sine of the critical angle is of the second medium divided by the index of the first medium. So we're going from glycerin, so that would be the first medium, to air, the second medium. All right, so the sine of the critical angle is N of the second medium, I'm going to say 2 over N sub 1. All right, so the air is the second medium, so I'm going to put that's 1.00, and the first one is 1.473. 1.473. So I want to know what the sine, well, what that fraction is, first of all. What is 1 divided by 1.473? I could have just done the inverse. There is that one. Okay, so that is 0.67888, whatever. Now I want to know what is the critical angle. So I just need the arc sine. So give me the arc sine of that. And I have 42.7 degrees. Oh, 756. 756, so about 42.8 degrees. So that is the critical angle. So if you're going to shine some light from glycerin to air, if you exceed 42.8 degrees as your angle of incident, that is going to be reflected directly back into the glycerin. All right, let's look at number 37. Assuming the wavelength is 589 nanometers, calculate the critical angles for the following materials when they're surrounded by air. Okay, so we're going to be doing it for zircon, fluorite, and ice. So I need that table again. I'm just going to look up here and write it down. There we go. For zircon, zircon is 1.923. N is 1.923 for zircon, and writing it down there. For fluorite, 1.434. 1.434. And for ice, how about that? Ice is, I saw it here. Here it is. At 0 degrees, which would be 32 degrees Fahrenheit, 1.309. 1.309. All right, so at least we've got that. Now I need my big fat book. Teacher's book is huge. Okay, so we just want to know what the critical angles are. So I think I'm just going to do it right here. We wrote down here that we need the critical angle is N2 over N1, where N2 is the second one. So we're going to go with 37. Here we go. For 37, we want to go for the first one. We're going to go from zircon to air. So air is our second one, and zircon is our first one. All right, so our critical angle is sine of the critical angle. That's little c for critical, of N2 over N1. And air was the second one, 1.000, and zircon was 1.923, 1.923. Okay, so let's see what that is. This time I'm just going to take the inverse of 1.923. 1.923, give me the inverse of that, please. And now give me the arc sine of that. 31.3, so that's going to be 31.3 degrees. Well, what am I saying? This is 0.52, is really 0.52. And then this right here, 31.3 is the critical angle, 0.5200, etc. Okay, so I kind of skipped a step there. So the critical angle is the arc sine of 0.52000, and that gives you 31.3 degrees. All right, the second one, we want to go from fluorite to air. So let's do the next one. Sine of critical sine. Want to go from, see, air is the second medium, and the first one is 1.434. All right, let's see what that is. 1.434, I want the inverse of that. 0.697, 0.69735. Okay, therefore, the critical angle is the arc sine arc sine of that is 44.2 degrees. 44.2 degrees. All right, so the next one, let's do the last one here in this problem. It's ice, from ice. So you can probably prove this yourself. So we've got the sine critical angle, N2 over N1, where N2 is the second medium, is air. N1 is 1.309. Let's see what that is. 1.309, and I want the inverse of that. And I want the arc sine of that. And I get 49.8 degrees. Oh, I skipped a step again. 0.67639. So therefore, the critical angle is 49.8 degrees. Trying to turn off this heater. There we go, 49.8 degrees. So that was it. That's all we had to do was figuring out what the critical angle is. And you'd get total internal reflection if you exceed that angle. All right, the last problem is really fun. It has to make you think. I had to read it a couple times. Here we go. Light traveling in air enters a flat side of a prism made of crown glass, and they tell you what the index of refraction is, 1.52, shown on the right. Will the light pass through the other side, or will it be totally internally reflected? Let me show you work. Okay, so in other words, will any of it go out, or will it all just go right back in? That's what we want to know. Now, interestingly enough, we see here that the light is going in exactly at 90 degrees and dash, dash, dash. Why is that? Well, what's the sign of 90? It's 1. So it's going to go straight through. So the question really is, what is the angle going to? First of all, I want to know what the critical angle is, and is that angle greater or smaller than to be able to go back in, or what? What am I trying to say? I'm going to turn this upside down. This is how I finally figured this out. And I realized that, remember, we want the normal. That's supposed to be 90 degrees. So what is the angle as it comes here before it hits the air? Well, I know that this is perfectly 90. I know that this is 45, so this one's got to be 45, so this one's got to be 45. So right here is 45 degrees. Okay, so let's find out what the critical angle is. We know that's 45 degrees there. That's upside down. So this one here is 45 degrees. Okay, so again, the theta sine of the critical angle is the n of the second material over n of the first material. And the second material here is air out here, and here is of the glass. And the n inside here is 1.52. So that's the first one. All right, so out here is air. I've got 1.000, and down here I have 1.52. So let's figure out what that is. 1.52, give me the inverse of that. There we go. So that is 0.65789. 65789. Okay, so now we want to know what the critical angle is. Theta sub little c. C for critical. All right, so we take the arc sine of that, arc sine, and we get 41.13. 41.13 degrees. So we notice that the critical angle is 41.3. And when it is leaving or trying to leave, it's at a 45-degree angle. So yes, 45-degree angle is greater than 41.3 degrees. So yes, you have it all total internal reflection. So none of the light will be refracted out. It will all go back in. I don't know what angle it is, but it's all going to go back in. All that light's going to stay in there. And it's because it did exceed the critical angle. So that's what we did in practice C. It's just practicing what does it mean to have a critical angle. And All you need is the index of refraction of the first medium and the second medium. The second medium in the numerator, the first medium in the denominator. And that's all I have. So I will see you next time.